But we're still not quite done because of the problem of back substituting. I'd like to go back and rewrite this in terms of the original variable y, or I'd like to go back and rewrite it in terms of the original limits of integration that we had in the original problem. In doing that, it's going to be useful to rewrite this expression and get rid of the sine of 2 theta. After all, the original y was expressed in terms of the sine of theta, not the sine of 2 theta. So let me just do that here. And say that this, in turn, is equal to a squared theta over 2 plus, well, the sine of 2 theta is twice the sine of theta times the cosine of theta. And so when there's a 4 in the denominator, what I'll get is sine of theta, cosine of theta over 2. I did that because I'm getting closer to the original terms that the problem started with, which was sine of theta. Okay. So let me write down the integral that we have now. The square root of a squared minus y squared dy is, so far, what we know is a squared theta over 2 plus sine theta cosine theta over 2 plus c. But I want to go back and rewrite this in terms of the original value, the original variable y. Well, what is theta in terms of y? Let's see. Y in terms of theta was given like this. So what is theta in terms of y? So here the fearsome arc sine rears its head, right? Theta is the angle so that y equals a sine of theta. So that means that theta is the arc sine, or sine inverse, of, well, y divided by a. So that's the first thing that shows up here, arc sine of y over a all over 2. That's this term. Theta is the arc sine of y over a divided by 2. What about the other side here? Well, sine and cosine, we knew what they were in terms of y and in terms of x, if you like. Sine is actually, maybe I'll put the a squared inside here. That makes it a little bit nicer. Plus, and then the other term is a squared sine of theta cosine of theta. So the a times sine of theta is just y. Maybe I'll write this a sine of theta a cosine of theta over 2 plus c. And so I get the same thing. And now here, a sine of theta, that's y. And what's the a times the cosine of theta? It's x, or if you like, it's the square root of a squared minus y squared. And so there I've rewritten everything back in terms of the original variable, y, and there's an answer. So I've done this indefinite integration of a form of this quadratic, this square root of something which is a constant minus y squared. Whenever you see that, the thing to think of is trigonometry. That's going to play into the sine squared plus cosine squared identity, and the way to exploit it is to make the substitution y equals a sine of theta. You could also make a substitution y equals a cosine of theta if you wanted to, and the result would come out to be exactly the same in the end.